everyone, I'm Mr. Pei. In today's video, I'm going to discuss with you regarding the SPM Physics Paper 3. And the experiment I'm going to discuss with you is one of the experiments from Form 5, Chapter 3, Electricity. The subtopic for the chapter is 3.3, E.M.F and internal resistance. And this is actually not a compulsory experiment where is able to find at your textbook, page 120. And actually, I was already discussed one of the sample question also regarding the activity 3.8. So this is actually the second question I'm going to discuss with you regarding the activity 3.8. However, there is some changes or modification on the activity 3.8, which I actually did some changes in this video. So where I already simplified the end of the experiment to become only one responding variable. So in the previous video, where the sample question regarding this activity 3.8, this actually got two responding variables where we want to observe the brightness of the bulb together with the measurement of the ammeter. In this video, the end of the experiment will be to study the effect of the connecting dry cell in series and parallel on brightness of the bulb. If you already watched my previous video regarding activity 3.8, you'll be more easier to understand the second question I'm going to discuss with you today. And in my previous video, I actually already discussed with you the detail of the format of paper 3. So in this video, I'm not going to discuss detail about the format of paper 3 again. So if you miss out the video, you may click the link at the corner to reach a video where the sample question number 1 regarding this experiment. Without further ado, let us continue the discussion today. Now, let us discuss about the type of question we are going to discuss in this video. If you already follow my previous video, you must already know that there are actually two types of questions in the physics SPM KSSM Paper 3. So first will be the question regarding the guided practical assignment. In BM, we know as Tugasan Amali berpandu. So in this side of the question, the procedure and diagram of the experiment is provided. And this is a video regarding the type of question about the Tugasan Amali berpandu. You may click the video link to reach the video and get to know more about this type of question. And the second type will be the non-guided practical assignment. And in BM, we know as Tugasan Amali Tidak berpandu. So the procedure and the diagram of the experiment is not provided. So this is a sample of the video where I have discussed about the type of question regarding Tugasan Amali Tidak berpandu previously. So again, you may click the link to reach the video. So in today's video, I'm going to discuss with you non-guided practical assignment or Tugasan Amali Tidak berpandu in this video. If you already follow my previous video, you must already know that there are two types of experiments you are going to see in the paper 3. So this will be hypothesis experiment, where involve about 5 MV and RV in your experiment. And normally the question will asking you to plot the graph where the data you get from your experiment. So the example of the experiment where related to this side of the experiment will be to study the relationship between the length and the resistance of the wire, where you have already go through the experiment together with your teacher, because this is one of the compulsory experiment in Form 5 syllabus experiment 3.2. And another example is sample question or sample experiment at Form 4 syllabus experiment 6.1 to study the relationship between the incident angle and the reflected angle. So again, this is a sample video where I actually discussed about the hypothesis experiment previously. You may click the video link to reach the video and get to know more about the hypothesis experiment. Then another type of the experiment will be non-hypothesis experiment. Mostly will be not involve many MV or RV data, and normally will be also not require the students to plot the graph. So here will be the example of the experiment where related to the non-hypothesis experiment. So here first will be to determine the specific heat of fusion of ice, where the experiment you also already go through together with your teacher. This is one of the compulsory experiment in Form 4 syllabus, Chapter 4, Experiment 4.1. The second example will be to determine the value of the gravitational acceleration and the activity 2.2, Form 4 syllabus. So you may see we just want to get the value of the gravitational acceleration through the experiment. Then the next will be to determine the critical angle of the glass ball. So again, this is one of the value we want to get through the experiment. So here I have a video clip which is related to the type of experiment regarding the non-hypothesis experiment. So you may click the link to reach the video and get to know more about this type of the experiment. So in this video, I'm going to discuss with you the type of experiment regarding the non-hypothesis experiment. Okay, so here will be the common question in paper 3 where I actually already go through with you all in previous video. Normally, this type of question will be test students about the science process skill. So all the science process skill question is actually quite similar to the science report you already did together with your teacher during the compulsory experiment. So the first, you need to state a suitable problem statement. Step 1, suitable inference. Step 1, suitable hypothesis, procedure, precaution, and also the verbal. So this is a normally distribution mark for this side of the question. And in this video, I'm going to teach you how to answer the question regarding the problem statement, inference, hypothesis, procedure. So that means that you need to know how to write the procedure in this video, where the non-hypothesis experiment are going to discuss. Then next will be the question regarding the tabulation of your data. Plot a graph, draw your observation, and the question regarding the data analysis, and normally will be asked you to state the relationship between the MV and RV of your experiment. Then the next will be the operational definition, deduction, and prediction. So in this video, I am going to teach you how to do the tabulation and the question relating to data analysis, how to give the answer for operational definition, and last will be the prediction. So now let us go through the theory about the activity 3.8 in your textbook, page 119 and 120. So the end of the experiment is actually to study the effect of connecting dry cell in series and parallel arrangement on E.M.F, potential difference, internal resistance, and current flow in the circuits. The first three effects I actually already discussed in my previous video. So you may click the link to get through the experiment and get to know more about this experiment. So today, I will be continue to discuss about the effect of the connecting dry cell in series and parallel arrangement on the current flow in the circuits. So this is a theory in your textbook, and actually I also already go through detail in my previous video. So now I will just explain again what you should know in this activity. So effect on the dry cell connected in series and parallel arrangement will be discussed about the effective internal resistance together with the total E.M.F. So from here, you can see that when the dry cells is arranged in series, so it may increase the effective internal resistance, where R represents as the internal resistance for one battery. So total 4 battery arranged in series will be have 4 out. Besides of that, so the dry cell arranged in series will be also increase the total E.M.F. The total E.M.F. So here one dry cell will be contribute to 1 sigma of the voltage. For example, the value is 1.5 volt. So the total E.M.F. contributed by the dry cell in series for this example will be 4E, 4 sigma, which is 4 times 1.5 equal to 6 volt. So that means when we arrange our dry cell in series, there will be more E.M.F. or voltage provided to the circuits. On the other hand, the dry cell in parallel, which will be arranged like this figure. So the battery will be arranged branches to one another. So the effect will be the effective internal resistance will be decreases, and the total E.M.F. contribute to the dry cell is actually as only one dry cell. Okay, so here let's say we're using one battery with a value of 1.5 volt. So when 4 of the battery arranged in parallel, so they will be also contribute only 1.5 volt. So from here, we are very clear that so with the dry cell arranged in series, they will be providing more E.M.F. That means the current flow in the circuit will be higher. And the brightness of the bulb, where the corresponding variable we are going to discuss in this video will be increases for the dry cell which is arranged in series. Okay, so the effective E.M.F. provided to the circuit may affect the current flow in the circuit. So as I mentioned, when we arrange our dry cell in series, so the current flow will increases, where you can measure by using the ammeter. And together we can observe the brightness of the bulb. So in this video, the corresponding variable will be only observation for the brightness of the bulb, because the ammeter is not provided in the apparatus checklist for this video, which is different with the sample question number 1, where we discussed previously. Okay, so this is what I want to emphasize, where the experiment we are going to discuss in this video will be only observing the brightness of the bulb. Now let's discuss what is the modification I already done for this video. Okay, so basically this is the activity 3.8 where you can get from your textbook page 119. And the modification for this video will be able to observe through this by these two figures. Okay, so from here the first changes will be I remove the voltmeter and ammeter for this experiment. So you can see for these two dry cell arrangement in series and parallel, there will be no any voltmeter or ammeter are going to use. Then second, I replace the resistor to bulb because we want to see the effect of the arrangement of the battery to the brightness of the bulb. Then again, I fix the numbers of battery for both arrangement, where I only using 2 battery compared to the actual experiment in the activity 3.8. There will be 2 battery for series circuit and 4 battery for the parallel circuits. Before we start our experiment, we must very clear that what is the MV, RV, and CV for the experiment. So in this experiment, the MV will be the arrangement of the dry cell, which is in the series and parallel. We want to see the relationship between the arrangement of the battery to the brightness of the bulb, where the brightness of the bulb indicate the current flow to the circuits. And the control variable here will be the numbers of dry cell, where will be 2 for these 2 experiments. So here, this is a theory we just discussed just now. So where the dry cell arranged in series will be providing higher current because of the high effective E.M.F. So the high current will be able to observe through the brightness of the bulb. Now let's go through the question together. So this is a candidate checklist. You are not allowed to work with apparatus in first 5 minutes. So if let's say you already watched my previous video, you may already know that the total duration for the test of paper 3 will be 45 minutes. So the 5 minutes will be used to check the apparatus and read the question. So you'll be have about 40 minutes balance to conducting the experiment and complete the question in your paper 3. So this period is used to check the apparatus list, read the question, and plan the experiment which is carried out. So you have to mark the box provided to check the material. So here, firstly, the apparatus are going to use will be bulb with holder with 1 quantity, battery holder will be 2, battery will be 2, and the connecting wire will be 4. So let's say you already checked your apparatus, they are functioning with correct quantity, you may take your checklist and immediately you may go to read your question and start to plan your experiment within these 5 minutes. Okay, so in this question, where I designed is actually quite different with the previous question I discussed with you all. So in this question, before we go to the experiment question, you actually give a situation and you need to answering some of the question regarding the science process skill. So this will be the first question. So diagram 1.1 and 1.2 shows the reading of ammeter. So here we have the reading of ammeter from the different arrangement of the battery. So here we also have 2 different arrangement of battery in diagram 1.1 and 1.2. So diagram 1.1 and 1.2 shows the reading of the ammeter from the different arrangement of battery. So with this, the reading of the ammeter change with different arrangement of the battery connecting to the circuit. So you can see the question is actually not given you what is the type of the arrangement in diagram 1.1 and 1.2. So you need to identify your own what is the type of arrangement of the battery in both diagrams here, and what is the changes of the ammeter. So basically, the diagram 1.1, you can see the arrangement of the battery is actually in one path. So the arrangement of battery in diagram 1.1 is actually in series. And then the arrangement of the battery in diagram 1.2, you can see they actually got 2 paths in the circuit. So it is very clear that the diagram 1.2 is actually parallel circuit. From the diagram 1.1, we may know that when the arrangement of the battery in series, the reading of ammeter is actually higher. So here, the 0 is actually at the left of the ammeter here. So that means the value of the ammeter, you can see from the diagram 1.1 is actually greater than 1.2, where the pointer of the ammeter for diagram 1.2 is actually closer to 0. So that means the value of the ammeter is actually smaller. So from here, we actually very clear that the arrangement of the dry cell or battery in series will be providing greater current where able to show or measure by the ammeter. And this is actually the logical observation where to meet our theory already learned in your textbook. Okay, so let us go through the first question here. So based on the information and observations, state one suitable problem statement. Okay, so this is the question where I actually haven't discussed with you in the sample question number 1 for this type of experiment. How we answer the question regarding the problem statement here. So here is a guide for you to answer type of question regarding the problem statement. So in different type of the experiment, we actually need to give the different answer for the problem statement. So here basically normally there will be have 2 situations. The first will be the normal hypothesis experiment. So where you can have a file reading and get another file responding variable. So for this side of the experiment, the problem statement can be given as is MV increases or decreases, causes RV increases or decreases. So here we have a sample answer for the experiment where we want to study the relationship between the length of the wire with the resistance of the circuit here. You may answer as the length of the wire, where represent the MV for the experiment, increases, causes the RV increases. So this is how we give the problem statement for this side of the experiment. But for this question, we are actually considered as a non-hypothesis experiment. And normally for this side of the experiment, they will have 2 MV and you need to do the comparison. Okay, so the answer have to give like this now. Is MV1 is more on the effect of the RV than MV2. So your answer must be together with question mark. Okay, so from this experiment, so we need to identify the MV and RV for the experiment. Okay, so from here, the reading of the ammeter is actually represented as the responding variable. Okay, so we want to see the effect of the RV here. That means we want to see the reading of the ammeter is higher or lower. And this depends on our MV. So the MV here will be the arrangement of the battery connecting to circuit. So here you can see our MV1 will be arrangement of battery in series. Our MV2 will be the arrangement of the battery in parallel. Okay, so this will be the MV1 and MV2 where I stated in the hot tips here. So the effect for the RV will be the reading of the ammeter. So here, which of the MV given higher? You actually can give lower, also no problem. Okay, so from here, I will give higher reading ammeter. So here, the MV1 will be referring to arrangement of the battery in series will produce higher reading of ammeter, which is the effect of the RV, where I stated in the hot tips here, compared to the battery which is arranged in parallel. So your answer will be like this. So is the battery arranged in series in the circuit? So this will be our MV1. Produce higher reading of ammeter. This will be our effect of RV. Then the battery arranged in parallel in circuit. This will be our MV2. So here must together with question mark. No question mark will be wrong. Okay, so this is how we answer the question about the problem statement. So you will get first mark. Okay, so the second will be a question asks you to stack one suitable inference. So the inference will be follow this format, where again you need to write the RV depends on MV. So just now we already identified the MV will be arrangement of the battery. And then the responding variable here will be the reading of the ammeter. So the RV here will be the reading of ammeter depends on the arrangement of the battery in the circuit. So this one will be not very hard. Okay, so the answer will be like this. Reading of the ammeter will be our RV depends on the arrangement of the battery in the circuit. So this will be our MV. So this is the way how we answer question about the inference. Then the next here will be the question asked to state one hypothesis, one suitable hypothesis. Okay, so again, so there are 2 types of the experiment. So you have 2 ways to answer the hypothesis. As I mentioned, if I say we have the type of the experiment regarding the hypothesis experiment, they will be normally involve 5 MV and RV. Okay, so the hypothesis will be straightforward. The length of the wire increases, the resistance increases. So this is an experiment you actually already did together with your teacher at the chapter 3, subtopic of 3.1. But for this experiment, there will be comparison between 2 different MV here. As I mentioned just now, there will be MV1 and MV2. So you must give the answer MV1 and then relate to the effect of the RV, then MV2. Okay, so here the MV1 will be, as per mentioned just now, will be the arrangement of the battery in series. MV2 will be arrangement of the battery in parallel. So the effect of the RV will be the reading of the ammeter here. Okay, so the answer will be like this. The battery arranged in series in the circuit produce higher reading of the ammeter. So you actually can simplify like this. Or you want to add on, the battery arranged in series in the circuit produce higher reading of ammeter than the battery arranged in parallel in the circuit. Okay, so you have two ways to answer this question. Okay, then for this example of question, the big question here will be the question where the candidate need to plan the experiment. So let us go through the question here. So with the use of the apparatus given, plan an experiment to investigate the hypothesis stated in 1A3. So 1A3 just now we also already give the hypothesis based on the situation or information given in the diagram 1.1 and 1.2. So you need to relate the hypothesis from the situation given just now in question A and then continue and plan your experiment. So in this question, your description should be including the arrangement of apparatus and the procedure of the experiment, which include one method of controlling the manipulated variable. So you need to give MV and one method of measuring the responding variable. So you need to know the RV for the experiment. Okay, so from here you can see that the procedure and diagram is not provided. So for this question will be the Amali Tidak berpandu. So you need to write the procedure and draw the diagram. Box here is actually to let you draw your diagram of the experiment. So this is the highlighted parts for the question. So where you need to use the apparatus given and plan an experiment to investigate the hypothesis in 1A3. Okay, so the hypothesis just now we already did is answer like this. So the battery arranged in series in the circuit produce higher reading of ammeter. So MV will be arrangement of the battery in the circuit. RV will be the reading of ammeter. However, if let's say you already go through the checklist, we actually not provided the ammeter. So the ammeter reading is actually able to indicate by observation of the bulb, where the brightness of the bulb is directly proportional to the reading of the ammeter. So that means if the bulb given brighter observation, they will be indicate that more current is flow in the circuits. So from here, we need to plan the experiment without the ammeter and instead of using the bulb here. Okay, so here, as I mentioned already, so you need to understand the MV and RV in your hypothesis and relate to the apparatus given in the checklist. Okay, so the MV will be arrangement of the particle, and then our RV now will be brightness of the bulb, since the ammeter is not provided in our checklist here. Okay, and then here we just involve 2 MV, and if I say you go through the question, so there will be no any graph will be asked you to plot. So this our experiment will be no hypothesis experiment. Okay, so now let's see together the diagram. Suppose you need to draw will be like this. Okay, so you need to give the drawing like this. So the question given us the battery and battery holder, and then bulbs and together with the switch and also the connecting wire. Okay, so the diagram here, you need to stack the type of the arrangement. Okay, so this is the arrangement of the dry cell or battery in series. Then for the second diagram will be like this. Okay, so you are providing 2 battery holder. So it's actually for you to conducting the experiment where study the effect of the dry cell in parallel to the brightness of the bulb here. So you can draw your diagram in schematic. Okay, let's say you draw the actual apparatus, so you need to give the name of the apparatus in your diagram here. In this question, 5 marks is given for the arrangement of the apparatus and procedure. So 2 marks will be given for correct diagram, which is series and parallel respectively. Okay, so now let us go to the second part. So how you write the procedure for this experiment. Okay, so the question asks to arrange your apparatus, and I already show you the actual arrangement of the apparatus already. Okay, then second, you need to give the procedure so that you can get the 5 marks here. So many candidates will ask the procedure should be write in passive or active sentence. In the correct way is actually you are advised to write in the passive sentence. And referring to the apparatus, you can see they are only providing one bulb with holder. Battery holder is only 2. Then battery will be 2 together with the connecting wire. So we are saying we want to run parallelly for this experiment. We actually need to have 2 bulbs, 3 battery holder, 4 battery, and 8 connecting wire. So that means the apparatus provider is actually not enough for you to conduct both experiments simultaneously. So that means here you need to do one of the arrangement of the battery first. Okay, so first you need to draw a label diagram of the apparatus setup. This one actually just now I already drew for you the schematic diagram regarding the arrangement of the drive cell in series and parallel. So basically it will be like this lah. Just now I already showed you. So you must plan your diagram early for this kind of question, so that when the candidate is already allowed to conduct the experiment, you can straight away follow the arrangement according to diagram you draw. Okay, so the first sentence will be like this. The circuit is connected and 2 batteries are connected in series as shown in the diagram A. Okay, so give 1 MV going to use. So the first MV here will be our series circuit, the first arrangement. So you can see the highlighted word here are using the passive words. So this is how we write the passive sentence for the procedure. So from here you can get 3 marks. So first 2 marks will be for diagram. Because of this question, we need to draw 2 diagrams. And then the first mark, the third mark here will be your first MV. Okay, then the third, you need to stack your first RV. So the first RV here will be the observation on the brightness of the bulb. Okay, so will be the switch is closed and the brightness of the bulb is observed. So this will be our RV1. And then, okay, so here you need to repeat your stack. Here is actually 1 and 2 only. For others, 4 MV or RV. Okay, so 4 MV and RV will be for the hypothesis experiment. Here is actually we have last MV2 . Okay, so you need to write like this. Step 1 and 2 is repeated. You can see I'm using again the passive sentence in my procedure here. So with the battery arranged in parallel as shown in the diagram B. So when I keep repeating step 1 and 2, so that means the observation of the bulb is actually repeating for our step 3 here. Okay, so here is the way how we write the procedure for the non-hypothesis of the experiment. You may actually draft the diagram and run the experiment first before you go to write the procedure. So in my simulation, I am actually using more apparatus and material compared to the checklist in this question, because I want to let you see more clearly the brightness of the bulb between the arrangement of the battery in series and parallel. But you may actually differentiate very clear the brightness of the bulb between the series and parallel. Okay, so now let me show you how we conduct this experiment.
Hi everyone, I'm Mr. Pei. In this video, I'm going to discuss with you an experiment which is related to the syllabus Form 5 Physics Chapter 3, subtopic 3.5, Electromotive force and the internal resistance. The experiment I'm going to discuss with you today is actually not a compulsory experiment in your syllabus, but this is very related to the subtopic 3.5 and to let you understand the problem solving involving to the E.M.F and also the resistance. So the title of the experiment is to compare the brightness of the bulb for the battery which is arranged in series and parallel circuits. So let us start our experiment. For this experiment, the apparatus needed is 4 battery, 3 battery holder, 2 switches, 2 bulbs, and also the wire with crocodile tip. Now let us start our experiment. So for connecting the dry cells in series circuit, so 1 battery holder will be going to use 2 batteries together with switch, light bulb, and also the crocodile tips. Okay, so for battery holder, so make sure you inserted at the first space at the battery holder, which is together with the terminal negative. So the bottom, there is only 1 button here, so it will be negative terminal. So the first terminal positive will be at the top and the right side here. Okay, so first inserted to the first space, and then this will be the second. Okay, so for 1 battery is about 1.5 volt here. So total will be about 3 volt. And the bulb and together with the switch is considered to not have any terminal. So you may straight away connecting each component in series, just according to the diagram. Be like this. Okay, so firstly, connect negative terminal, which is at the bottom part of the dry cell holder, and then to the one of the terminal of the switch. Okay, and then next will be connecting to the another side of the switch. Okay, make sure the contact tape connect to the metal parts of the switch, and then straight away connecting to the side of the bulb holder. Okay, then next will be keep it another side. Okay, so the terminal positive will be at second button from the right here, because we're using 2 battery or dry cell which is connecting in series. Okay, so you may close your switch, okay, and observe your bulb. Okay, so you can see the bulbs light up. Okay, so now we want to compare the brightness of the bulb with different connection. There will be the dry cell which is connecting in parallel circuit. So now let me show you how to connect the dry cell in parallel circuits, and then you need to compare which bulb will have the brightest bulb. Okay, so for connecting the dry cell in parallel circuits, you need to have 2 dry cell holder, 2 battery, 1 switch, 1 bulb, and together with the wire with contacts. Okay, so for battery or dry cell connecting in parallel, so again make sure you place your battery at the first space of the dry cell holder, which is together with negative terminal of the dry cell holder. Okay, the second battery will be at another dry cell holder, which is also at the first space. So now you can see the constant variable for this experiment will be same numbers of dry cell. Okay. Connect your positive terminal of the first dry cell holder at the top side of the button to another top and the right side of the dry cell holder. Okay, so this will be connecting your dry cell in parallel circuit. Okay, and then again, okay, so we arrange the others component according to diagram. So will be same as the series circuit. Okay, so the dry cell holder negative terminal here need to connect to another terminal, negative terminal of the another dry cell holder. Okay, so now our battery or dry cells is already arranged in the parallel circuit. Okay, so after that, so we'll be connecting our dry cell holder to the switch. Okay, so make sure connect to the metal part of the switch. Another side will be at the positive terminal. Okay, and then the next, connect the another side of the switch to the another side of the bulb holder. Okay, so after that, connect another side of the bulb holder to the negative terminal of the dry cell holder. So it will be like this. Okay, so one will be at positive, another one will be at the negative.
This is a close-up view to show you that how two crocodile clip connecting at the terminal positive and terminal negative at the battery holder. So firstly, make sure that the metal part of the crocodile clip connecting to the another crocodile clip at the battery holder. This is similar also at the terminal negative. The two crocodile clip of the metal parts contact to each other.
Now let us compare the brightness of the bulb for the dry cell which is connected in series together with the dry cell which is connected in parallel. So you must close your switch. Okay, so you can see. So the bulb is light up for the series circuit. So now we want to compare the brightness of the bulb for parallel circuit. So the bulb for the parallel circuit is actually dimmer compared to the bulb when the dry cell is connected in the series. Okay, so that means it's very clear that the connection of the battery in series will be better compared to the dry cell connects in parallel. So this is because the current flowing in the dry cell which is connected in series is greater compared to the dry cell which is connected in parallel. Because the electromotive force provided for the dry cell in series circuits is greater compared to the E.M.F provided to the parallel circuit here. Okay, so the E.M.F here for the series circuit will be about 1.5 times 2 battery. Okay, so another side here will be only considered as one battery power supply, which is only 1.5 volt. Okay, you can actually using the ammeter to measure the current flowing in both circuit, and we expected the battery or dry cell which is connected in series will be have the greater reading of the ammeter, which is showing that the current flow is higher for the dry cell which is connecting in series circuit, as the E.M.F provided for the circuit is greater compared to the circuit where the dry cell is connecting in the back. So that's all for my sharing today. Thank you.
Welcome back. Now let us continue the next question. Okay, so tabulate your data in the space below. So after your experiment, actually you already know the relationship between the arrangement of the battery and the brightness of the bulb. Okay, so for tabulation, basically you need to know all the data of MV and RV related. So here our MV will be the arrangement of the battery and the RV will be the brightness of the bulb. Okay, so basically, so the MV here will be the arrangement of the bulb. the RV here will be the brightness of the bulb. And the arrangement is very clear that we have two only, which is series and parallel. So after the experiment, you may see that the brightness of the bulb for series is actually brighter. You suppose will be get brighter, and the parallel will be actually dimmer. So your answer is actually will be very straightforward for this sample question. Next, based on the result in C, so where your result is like this. So state the relationship between the arrangement of the battery with the brightness of the bulb. So this is an example question for the data analysis. So from here, you may see that when the arrangement of the battery is in series, so the bulb will be brighter. So your answer will be battery arranged in series produce brighter bulb. So this question is actually very straightforward and easy to understand. Then the next here, give you a reason for your answer in D1. Okay, so why battery arranged in series will be brighter? So this one is the theory I actually discussed with you just now. So where the battery arranged in series will be providing higher E.M.F. So providing more voltage to the circuit, so the current flow will be more. So answer will be battery arranged in series provides higher electromotive force. So this will be the answer for this question. Okay, so now we go to our next question. So based on the experiment, state the operational definition for parallel circuits. Okay, so how we write the answer regarding this type of question? Okay, so this is tips to help you answering the question regarding operational definition. So you must involve your RV plus method. Okay, so it'll be like this. So the parallel circuit is an arrangement of battery that produce dimmer bulb. So the dimmer bulb will be our responding variable when the electrical circuit is connected completely. So this is the method we conducted in our experiment. This is the method how we answering the operational definition question here. So the last question here will be about the prediction of the experiment. So here, predict what happens to the brightness of the bulb if one more battery is arranged in series to the existing two battery arranged in series in experiment question B explained. So here we have two marks. The first mark will be the observation of the brightness of the bulb when we add on another bulb to the existing arrangement of the battery in series. So the diagram will be probably like this. So the question is actually asked the observation of the bulb when we add on one more battery to the circuit here. So as we already discussed the theory, when the more battery added in series, so the more E.M.F. will be supplied to the circuit. So the current flow will be more. So the bulb will be expected more brighter. So here, answer will be the bulb light up more brighter will be the first reason. The total effective motive force provided to the circuit increases. So this is the reason. This is all the discussion regarding this video. Thank you everyone. I hope that my video clip can help you to understand how to answering the question in paper 3. That's all. Bye bye. See you.